All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 6 times x plus 7. Okay, for the math knowledge question, we want to know how many trips we would need to make. So we have to deliver 75,000 condensers, and she can use a small truck or a big truck. And each truck makes only a single trip. So the two larger trucks are going to carry 15,000 each, so that's 30,000. And we need a certain number of smaller trucks, and they each can carry 12,000. And the total load is 75,000. So those smaller trucks are going to be left to carry 45,000, because the two bigger ones can take 30,000. And so 75,000 minus the 30 is 45. And then if you divide 45,000 divided by 12,000 is 3.75. And so we have to have 4 smaller trucks. Okay? So we are looking at lesson 18 today. We're going to be looking at advanced word problems. We are skipping lesson 17 because that's the proof of the Pythagorean theorem and proof of similarity. And we dealt with proofs last year in geometry. So we're not going to deal with proofs again in pre-calculus. So hopefully you'll understand how advanced word problems work. You have probably dealt with some of them in Algebra 2. Some of them may be review, some of them may be new. There are a lot of different kinds of problems that we can do, so we're just going to look at one of each example pretty much. So we have the number of blues was 4 less than the number of whites and greens. So we have blues, whites, and greens, so that means we're going to have 3 equations because we have 3 variables. So the first one, the number of blues, when it says was, that's your equal sign, was or is, 4 less, so that's going to be subtracting your blues, or your whites and your greens. So blues equals the whites plus the greens less 4. Also, the number of greens equaled the sum of the blues and the whites. So the greens equaled blue and whites. How many of each were there if there were twice as many blues as whites? So some people get confused on this. Were there more blues or more whites? There were more blues and there were twice as many of them. So we're going to multiply the whites by 2. Okay, so now we're going to plug in this B equals 2W into the top 2 equations. So B is going to become 2W, and then G equals, instead of B, we're going to have 2W plus W. So the one that'll simplify is this bottom one, and it'll become G equals 3W, which we can plug in right here. So we have 2W equals W plus 3W minus 4. So 2W equals 4W minus 4. And then if I subtract this 4W, I'll get negative 2W equals negative 4. So that means that we have 2 whites. If we have 2 whites, we're going to have 6 greens, and we're going to have 4 blues. And so that would be how you can work through that one. You're basically just going to set up a system of equations and then go from there. Okay, so now we're going to look at another example. We have quarters, nickels, and dimes totaled $20, or no, totaled 20, and the value was $1.90. How many of each kind were there if we have 4 times as many nickels as quarters? So we know that our quarters plus our nickels plus our dimes equals 20. And then the value. So a quarter is 25 cents, A nickel is 5 cents, and a dime is 10 cents. And we have $1.90, so that means we have 190 cents. So if you do it that way, you don't have to have any decimals in your equation. You can do 0.25Q plus 0.05N plus 0.1D equals 1.9 if you want, but it makes it a lot easier if you have no decimals. Okay, and then it says there were 4 times as many nickels as quarters. So do we have more nickels or more quarters? We have more nickels, so we're going to have to multiply the quarters by 4. So those are our 3 equations. So I think it's easiest to start off by plugging n equals 4q into your top 2 equations. So if n is 4q, q plus 4q is 5q, plus d equals 20. And then here, 5 times 4q would be 20q. So 25q plus 20q would be 45q plus 10d equals 190. And then you can do substitution or elimination. I personally prefer elimination, but you could solve for d and plug it in and get the same answer that I'm going to do an elimination. It's your choice. But I'm going to multiply the top equation by -10 so that I can eliminate it. So 5 times -10 is -50. And then minus 10d equals -200. So if you add, you'll get -5q. Those will cancel, and -10. So q would equal 2. If q equals 2, that means that n equals 8. And if we have a total of 20, 8 plus 2 is 10. So that means that the dimes had to be the other remaining 10. And then these are pretty easy to check. 25 cents for your quarters, that's 50 cents. 10 dimes at 10 cents each is $1, 100 cents. And then 8 nickels is 40 cents. And that adds up to 190, which is what they told us we had. So that's how you can check on those if you want. You will not get decimals on these. You only are going to get positive integers. And the reason is because you can't have a fraction of a quarter or a fraction of a nickel or dime. You only have whole pieces. And you can't have a negative number of quarters. So only positive integers here. Looking at another one. This is a direct variation and an inverse variation. So it says reds vary directly as blue squared and inversely as greens. So when you vary directly, it's going to be something equals k times b. That's a direct variation. And if you vary inversely, it's going to be a equals k over b. So it says reds vary directly. So whenever you see the word vary, that's where you put your equal sign. So reds varied directly as blue. That means that the blues are going to go in the numerator with this k. And your k is your constant. And it says very directly as blues squared. So you have to make sure you square that. And then inversely as greens. So inversely means it goes in the denominator to divide. So that's your equation that you're going to want to use. When you have 80 reds, we're going to plug in 80 for R. We have 4 blues and 2 greens. And so now we can solve for our k. So I'm going to cross multiply and get 160 equals 16k. And so k equals 10. Now we can plug it back in and find out how many reds we have. So how many reds were there when we have 8 blues, so 8 squared, and 10 greens? And then our k is also 10, because that's what we just found. You can cancel these 10s, basically, which will leave you with r equals 8 squared, which is 64. So we have 64 reds. So that's how you deal with a direct and an inverse variation question. Now we're going to look at the sum of digits of a two-digit counting number. So when you have a counting number, you have the tens digit and the units digit. And together, whatever these two numbers are, add up to 5. Because it says the sum of the digits is 5. So that could be a 1 and a 5, or a 2 and a 3, or a 3 and a 2. I mean, a 1 and a 4, sorry. Or a 2 and a 3, or a 3 and a 2, or a 4 and a 1. So one of those 4 combinations. If your digits are reversed, that means that it's going to be UT. And so I'm going to go back to probably kindergarten, maybe first grade. Do y'all remember dealing with those number cubes? You would have one that represented 1, and then you have a stack of 10, and then you have a block that represented 100. This number, however many are there, it's getting multiplied by 10. If I'm saying 15, that means 1 10 and 5 ones. If I said 45, that would mean 4 10s and then 5 ones. So we don't know how many U's and how many T's we have, but when the digits are reversed, that value is going to be 10 times U plus T. And so the value is 9 more than the original. Well, the original value is 10T plus U. So that's the equation that you would have. From there, we're going to subtract the T and the U over here. And so 10U minus U is 9U. And then T minus 10T is going to be negative 9T equals 9. So I have this equation, T plus U equals 5. And I have 9U minus 9T equals 9. So you can either do substitution or elimination. I'm going to do substitution, but I'm not going to multiply this equation by anything. I'm actually going to divide this one by 9. And so if I divide it by 9, I'm going to have U minus T equals 1. And then we know that U plus T equals 5. So if you add those together, you're going to get 2U equals 6. So U is going to be 3. And if U is 3, that means that T is 2. And it asks for the original number. This is our original number, TU. So our original number is 23. Okay? So that's how you can deal with your sum of digits of a two-digit counting number. So some people hate working through these. They just get confused or they hate working it out. If you want to try and do guess and check on these, that's fine with me. I don't really care. You just have to be able to figure out what your original number is. Okay, so now we're going to look at another example. We did these back in Algebra 2. So you're going to make 3 boxes. And we're trying to get 1,000 gallons of a mixture. So that's what we're trying to end up with. And to get it that was 56% alcohol, it was necessary to mix a 20% alcohol solution with an 80% alcohol solution. And how much of each was required. So we're adding these two together to make it equal the last one. Since all 3 of these percentages are in alcohol, we don't need to find the other percentages. You just have to make sure that your percentages are all in the same thing. So if you wanted to do all in other stuff, because we don't know what else is mixed with the alcohol, then you could do that. So we know that we have X amount for this one and Y amount for this one. And together, X plus Y is going to equal 1,000. So that means that Y would equal 1,000 minus x. So I'm going to plug that in here for y. And so if you multiply, you'll have 20% times x. So 20% is 0.2. And then we'll have 1,000 minus x times 0.8, because that's what 80% is as a decimal. And then we'll have 1,000 times 0.56 for 56%. Okay, from there, you're just going to distribute. So you're going to have 0.2x, and then 1,000 times 0.8 is 8. Whoops, that should be a plus sign. Is 800, and then minus 0.8x equals 560. So then we can combine our like terms here. So we'll get negative 0.6x plus 800 equals 560. And then if you subtract 800, you'll have negative 0.6x equals negative 240. And then if you divide by negative 0.6, your x value is going to be 400. So that means that your y value would have to equal 600. And so the way you write your answer for these, you need 400 gallons of the 20% solution, because that's what your x went with. And then you need 600 gallons of the 80% solution. And so that would be your answer. If you just say 400 and 600, I don't know if you need 400 of the 20 or of the 80%. So you got to specify. You need 400 of which solution. And so that's how you can work through those. We're going to look at another one similar to this. We have how many liters of a 64% solution must be added to 77 liters to get a 42% solution. So again, you're going to start off with 3 boxes. And we're taking something and adding it to another one to get the third solution. If it says evaporated or subtracting, that's where you would do a subtraction instead of an addition. So we don't know how much we're adding here, but we know that it's a 64% glycol solution. And then we know we have 77 liters here of this 23% glycol. And then we are trying to get a 42% glycol solution. And so the amount is going to be x plus 77, because those are the two amounts that we're going to add together. So now we're going to multiply the amount times the percentage. So x times 0.64 plus 77 times 0.23 equals x plus 77 times 0.42. So if you multiply 77 times 0.23, you get 17.71. And then you'll have 0.42x plus 32.34. And then from there, you're just going to solve for your x. So 64% minus 42% is 22%, so 0.22. And then if you subtract 32.34 minus 17.71, you'll get 14.63. And then if you divide, you should get 66.5. And it is possible that you're going to get decimals on these, and that's okay. And so it says, how many liters are we going to add to our solution to get the last solution? So we don't have but one number here. So 66.5 liters is the only answer we need to have. So it just asked about how much we're adding here. We only had one variable. So we don't have to differentiate what percentage it is. since there's only one number that we're looking for. Okay, so now we're going to look at one more example. The weight of the carbon was 113 grams. What is the total weight of the compound? So this is going to be where you set up ratios. And it may seem like it's more of a chemistry question, but the book is just trying to help you with some math so that when you do it in your science class, it's a little bit easier. These numbers here, they're always going to give you. So even if you think you know them, that's fine. They're always going to tell them to you, so you don't have to worry about memorizing them. So we know that the carbon was 113, but we don't know what the total was. And so that's what we're going to be looking for. What we need to do is find for one molecule. So one molecule, the weight of the carbon, each carbon is 12, and there are 3 of them. So the carbon weighed 36. And then the total weight of the one compound would be 36 plus each hydrogen weighs 1, so 7. And then there's 1 chlorine, and it weighs 35. So plus 35. So if you add those together, you'll get 78. And so carbon was 36 out of the total of the 78. And so now you're going to cross multiply. And then if you divide, the total weight was 244.83 grams. Okay, so that would be your answer for that one. They don't often get decimals for these, but if you do, that's okay. Just make sure that you added, multiplied correctly, and you divided correctly. But that's how you would do those. So hopefully most of that was review from Algebra 2. If y'all need to, as you're doing your homework, y'all are welcome to go through the video again, find the problem you're having trouble with, and rewatch that one example. And then hopefully it'll help you a little bit on your homework. So for your homework, you do get to omit 8 and 14. Those are both geometry concepts, so we get to skip those in pre-calc. So make sure you do the other questions tonight so we can go over the problems that you have tomorrow.